Hey guys, real quick recap of the rules we learned last time. If you need to know all the little details, watch the last video. I just want to go over it again real quick for day 2 here because it's so important that we know all these things. We have 4 types of special segments called median, angle bisector, perpendicular bisector, and altitude. They all do special things, but they have things that make them unique and things that they have in common. For instance, a median connects a vertex to the midpoint of the opposite side. An angle bisector starts at a vertex and cuts the vertex in half. A perpendicular bisector doesn't mention the word vertex. Altitude start at a vertex and is perpendicular to the opposite side. All 3 of those start at a vertex. So that might be a little confusing, but does an angle bisector, for instance, have to hit the midpoint? Does this have to be the midpoint? The answer is no. It can be. We're going to talk about that in a second. But like a median has to hit a midpoint, period. Must hit a midpoint. Whereas other line segments don't necessarily have to do that, except this guy. What does a perpendicular bisector have to do? It has to hit the midpoint. So like in this picture, this red line would be a median because a perpendicular bisector and a median both have to hit a midpoint of the opposite side or of a side. But the difference with this one is instead of going through the vertex, the perpendicular bisector has to make a right angle. So they have things that are in common, but they also have distinct differences. And you need to read through these and make sure you understand all these properties. I've posted this file on Schoology if you need extra help. But the information on each of these slides is non-negotiable. Like you have to understand and know these properties. You have to be able to say them and recall them quickly from memory. A few things that might make it a little bit easier, like a centroid is the center of gravity. The center of gravity is going to be inside the shape. So you know centroids are going to always be inside the shape. Angle bisectors meet at the end center. The end center, look at the letters IN. It is inside equidistant from the sides. End center, inside, equidistant from the sides. Circumcenter is equidistant from the vertices. The only one that doesn't mention vertex is equidistant from the vertices. So the point equidistant from the vertices comes from the line perpendicular bisectors that don't have to touch the vertex. Look at that. Does this have to go through the vertex? No. Altitudes, orthocenter, you just got to know it. Ayo, ayo. I don't know if that helps. Little things like that help me remember things. But you need to have an idea of what these look like and how they act. Now, I do want to show you, and I showed you this in the last video, like this big situation. There's a lot of things that we can get from this. First, I know that this is a scalene acute triangle because all my special points, if you can find them here, like G, J, I, and H, are inside the triangle. As I move the triangle, watch point H and point G. Point H and G as I change the triangle up. So it's still acute, it's still acute, it's still acute. Those points are in. Now they're on, right on, dude. When it's a right triangle, they're on the triangle. Point G is on the midpoint of the hypotenuse. Point H is on the right angle. Now, it's not a perfect right angle, so it's a little bit off when I zoom in. If I got it perfectly, it would be just right on there. But, I mean, even still, if I zoom in, I can tell it misses. But if it was a perfect right angle, it would be on the right angle. The orthocenter is the right angle of a right triangle. I know that this is a scalene triangle because all the lines are all different lines. The green, the pink, the blue, the black, they're all separate lines. Now, what would happen if I change it up a little bit here? Could I make this triangle be isosceles? Yes, right now I know it's an isosceles obtuse triangle. How do I know that? Well, G and H are outside the triangle. That's the circumcenter and the orthocenter. They're outside the triangle. I know it's obtuse. And then from vertex C, what's going on? What used to be 4 lines, when I merge them like this, when I put it together, now they're 1 line. Now, we know that this happens when you have an isosceles triangle. Now, the base angles, like if you look at A, it's still separate lines. If you look at B, those are still separate lines. But from vertex C, the vertex angle, all those lines became 1. Now, I didn't get it perfect. If I zoom in, can we still see that they are actually 4 separate lines? Yes. If I made it perfectly isosceles, it would be exactly 1 line. At no point do 2 of them overlap. It's either they're 4 distinct lines or they are a single line. There's never just 2 or just 3. It's either 1 all by itself or 4 all together. So I know that this is obtuse. I know it's isosceles. Now, what would happen if I, let's make it an equilateral triangle. Oh, by the way, when it was isosceles, like here's another isosceles triangle. Look at the 4 points, G, J, I, and H. They are 4 separate points still. They're on a line, but they're separate points. What happens as I bring them together, bring them together, bring them together? They become a single point. And it's really hard to do. I'm not going to get this perfect, but basically, when I make this exactly equilateral the best I can, that one spot is now all 4 spots. And our lines came together from all 3 vertices. So this one spot is an incenter, it's a circumcenter, it's a centroid, it's an orthocenter, it's all 4. That means it has the properties of all 4. Remember that an incenter is inside, equidistant from the sides. Remember that a centroid is the center of gravity. Well, sometimes, always, or never. The centroid is equidistant from the sides. It's sometimes. Right now, on an equilateral triangle, it is. You see, when I zoom in, you can see they're still a little bit off. But assuming that it was perfectly equilateral, they would be perfectly on top of each other. So all of the properties are shared on an equilateral triangle. Right now, this one point represents all 4 points, and it has all the properties. So every point has the properties of the other points when it's equilateral. So can a circumcenter be the center of gravity? Yes, it can. It doesn't have to be, but it can. It is right now. So that's something we definitely have to keep in mind going forward. And then the most missed situation, this is where students struggle the most, is take a look at this list. Look what I'm telling you here. We have 5 things, right? Do you see these 5 things? If any 2 of them occur at the same time, then they must be all 5 of them. There's no in between. So if you pick any 2 of those, what do I mean by that? Okay, let's make a triangle here. Let's pretend that we know that this triangle is isosceles. Let's say that these 2 sides are equal. And we know that this line is an angle bisector. Okay? So if you know it's isosceles and you know it's an angle bisector, so is that 2 of our options? Angle bisector, isosceles? Yes. What does that mean? That means it has to be the rest of them. That means it has to be an altitude, it has to be a median, it has to be a perpendicular bisector. You can't have just 2 of those things. You either have one of them or you have all of them. There's no in between. And so if you pick any 2, you know it's all of them. Now, the thing is, you have to make these connections. Like maybe, for instance, maybe you know that this side's like 9 and you know that this side's 10, and the question asks you for this. Well, if you didn't realize it was a 90-degree angle, there'd be no way to do it. But once you're like, oh, well, it's a right triangle, therefore I know that a squared plus b squared equals c squared. So 9 squared plus 10 squared equals c squared. So c equals the square root. This would be 81 plus 100 of 181. And if, and so that's how long this side would be. But you only would know to do that if you knew you had a right angle there. Okay, what about another situation? So let's say we know that it is, that you have some line segment and you know it's a median and you know it's an altitude. You know it's an altitude and a median, both those things. Well, now we know for sure that it's an angle bisector. It's a perpendicular bisector, which it's already doing, right? Isn't it already perpendicular at the midpoint? And you know it's isosceles. Well, that means these angles are equal. Look at all we know. So we started with a median and an altitude, and now we know all of this. And if you don't make these connections, you're going to get really stuck. So I could keep going and going, but the bottom line is if 2 of these things occur, you know you have them all. Now let me be very, 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 very clear. What if I were to draw, actually let me delete a few more things. So let's say we have this situation. Let's see what we got here. So what if I have this side is a median and this is an altitude? Is that what I'm talking about? No, they have to happen from the same corner. There's nothing else we would know here. It has to happen from the same corner. That's not what I'm talking about. They have to occur at the same time on the same corner. On the same corner. I should have added that in there. All right, so that's a wrap up of a lot of the stuff we talked about. You need to know these things. Go watch the original video if you need in-depth explanation of all of the different properties and all of the different visuals. But let's keep going forward. It's a fun chapter.